Okay, this lesson is the polyatomics of the tetrals, connectogens, chalcogens, and we will do another lesson next time on the halogens and hydrogen. So we're going to look at carbon. We're going to build these according to directions. So I'm going to show you how to build these as fast as we can. So the first one's going to be the carbon dioxide, right? And it's going to have two red oxygens with one short bond each. So we're going to have four carbons, almost always have four bonds. So we're going to put one oxygen here and one on the other side. This is the single bonds. We're only looking at the ion here. So we're going to actually, if we're not using a hole, we're just going to leave it like so. And so this is carbonite, excuse me, I said carbon dioxide. It's carbonite, it's an ion. So it has a -2 charge, right? And why does it have a -2 charge? Well, one of this usually, let me use one of these. I've got a two-holer here. It's not a two-holer, so should have a couple two-holers. There's a two-holer. There's a two-holer. And there's the two-holer. A lot of times we just use two holes with oxygen. So what's going on here? The carbon has two holes. The oxygens have two holes in the ion. This acts together as an anion, negative ion, and it's got two ends where oxygens are available for taking bonds. So this is the polyatomic with carbon. It's called carbonite and carbonate. Okay, so the lower one's always ite, and this one's ate. So the way to think about this is oxygen is taking a bite out of this, and ate is ate it all. So that's the way I used to say it in a lot of my classes. So we'll stick with that. I know it sounds kind of corny, but let's go ahead and pull up. The next one here is going to be, and I'm again just following directions in your in here. So we're going to take the next thing we're going to do is take two red oxygens, one short bond each. So we're going to do that. I'm going to go ahead and put two oxygen. I'm not going to care whether it's two or three, four whole, whatever oxygens. We're just going to use whatever ones I can grab here. Okay, so there's the two short bonds. So far it looks like this. But now it has a third red oxygen with two long bonds. So we're going to get two of the longer bonds here and put them on. That's carbon. That one's too tight. Let me go with a different one. That one and this one. So carbons, all four bonds are going to be used up here. Sometimes I got two kits sometimes with pieces and they don't always fit real well. So, and then they're both going to attach to the same oxygen. So I'm grabbing one oxygen and putting the double bond. You have to bend it a little bit like so. And so this is carbonate. So carbonite, carbonate. Okay. And again, notice it has, there's nothing available here, but there's one and two free. So it still has a still -2 charge because there's still a hole in each one of these oxygens. So that is what's the difference between carbonate and carbonite. Ite is one less oxygen, carbonate. I'm just going to lay them like that for right now. All right, and then silicon does the same thing, and I have silicon here already with some short bonds. And in this, it says just all four of them use a short bond, so we just grab four oxygens and add it to the silicon. Remember, it looks like a metal with four. It's a semi-metal technically, right? So this is silicate, right? Or it's called orthosilicate. Everything's somewhat of a right angle, right? So there is a four, as you see, it makes a nice tetrahedral. And so there is our three tetrals, right? They make four bonds. This one made all four bonds. This one still made four bonds, This one is still got some electrons out there. If I have my little paddles handy, I'll go look long. If I can't find them, I'll go, oh, there's one right there. And what's going on here is that's 2 electrons. Here's the other 2, and the little paddles we have. Both you all have 2 paddles at least, right? So that's what's going on with carbonite. Carbonate has 2, 4, 6, 8. Each one of these bonds is 2 electrons. So that has its octet, 2, 4, 6, 8. There's its octet, 2, 4, 6, 8. We're going to learn octets really matter in chemistry. So that's the tetrails. Let's look at the pictograms, right? So we're going to scroll down a little bit and look at that. And here we're going to use nitrogen, and nitrogen is going to have, again, red oxygen with 2 bonds. So I'm going to grab a 4-sided, put on some long bonds. This is 2 long bonds. So I'm going to grab 2 long bonds and grab an oxygen. Putting it together here. When I say two long bonds, that's going to make a double bond, what we call double bond here, right? All right, and then add the 3rd oxygen. Ooh, let's see, I'm wrong line here. Add the 2nd oxygen with just a short bond. So we're just going to grab a little short bond here, my thousands of little short bonds, and put it on the nitrogen, right? And there is the nitrous. This is called nitrite, ITE. Remember, ITE is the smaller version, right? So that's nitrate. Let's go ahead and make the nitrate. Nitrate is the next baby, which is, again, with 2 long bonds. So that means a double bond. So I'm going to grab two double bonds here. Sometimes these older kits don't fit real easily. One will be loose and one's real tight. There we go. So there is the first double bond in that, right? And I'm reading in part 1 there still, the nitrogen, group 5 rather. So group 5 nitrogen. You actually will have to stop with this group because you just don't have enough oxygens, right? I'm going to keep on going. So you'll take a picture at this point. Make sure your name and date's down here. Take a picture at this point, and then we start on part 2. We start building these guys, right? So here's the double bond, and we have a 2nd and 3rd with just a single bond. So we grab 2 single bonds and add it to the nitrogen. Don't put it on the wrong atom here. And another single bond. And so again, this is nitrite, this is nitrate, oxygen 8 this more. So notice it has 1 more oxygen, and so they both have a double bond. So but it's interesting because of the way nitrogen can change its configuration. They both still are -1. Okay, so why is that? Well, we'll get into this much later, but -2, -2, so this has got to be -1. So this is going to be +5. And then -2, -2, -2, that's -6. So to make it -1, this has to again be +5. So it's interesting how that works. There's actually a couple other variations of this. So, but we're just going to do the nitrate and nitrites. I'm going to move these off the side for a second. And then let's do the phosphorus. Okay, phosphorus. You can barely see it here. At PO3, we just didn't have enough oxygens. I do, so I'm gonna go ahead and build it. But in the we're only required to build the phosphate, and phosphate's a very important molecule. So we'll go ahead and find a 4-sided. Here's one, and it says that we just use. Let's see, 2 long bonds to start with to connect to an oxygen. We'll leave this little bond on here because we're going to need them anyway. Okay, that's 2. Got some long bonds here. 1 long bond attached to a oxygen. Let's get another long bond and attach it to the other side. So we have a double bonded, like so, right? And then there are 3 other oxygens on here. We're just going to use the little short bonds here and pop on 3 more oxygens. Okay, so that, let me grab an oxygen over here. What's that? I got a whole box full over here somewhere. All right, so there is phosphate. Now, phosphate, we're going to see this in biochem a lot, but phosphate is PO4 minus 3, right? How's that work? 2, 4, 6, 8 negatives plus 5 makes this minus 3. The phosphorus can take on a plus 5. Remember the word pycno, 5? These are plus 5 also, right? So that's how we get these charges. This is phosphate. There is one that's one less oxygen, one less of these oxygens, and that's PO3. That's phosphite. It's kind of grayed out there. So this is where you also stop and take a picture and go from there, right? Okay, so this is the pycnogens, tetrals right here. You don't have these many, so you have to build these in steps. All right, last is chalcogens. Okay, so the first is actually oxygen itself. And what's going on that is it's called a peroxide. A peroxide is normally oxygen makes a double bond with itself. We saw that with the diatomic, right? But what this is doing is, let's see, is this double bond here between these? This is part 3 here. Get down to part 3. 2 red oxygens with 2 long bonds. So yeah, it still makes a double bond. So let's go ahead and grab double bond here. There's 1 bond. So it's like oxygen, except it goes beyond and makes it's still got a charge on each side here, and so this actually blows up. This is very, very unstable. So there's electrons on either side here. It's not O2. This is 2 oxygens in a row. So this is called peroxide. Okay, that's the only one the oxygen makes with itself, right? It also makes a molecule called ozone, but this is actually an ion. There's two negatives, 1 on each side here on this one. All right, let's do sulfur, big old sulfurs here, right? So I got some sulfur handy here, and I'm going to go ahead and see what we got here. We got a sulfite and a sulfate. So the sulfite is double bonded oxygen. Let's see, I've got one right here. Start cannibalizing the other parts. Put a double bond to the sulfur. Okay, that's what the direction said, right? So there's 1 oxygen, and then the other 2, the second and third, are just plain single bonds. So we just grab some hydrogen, some oxygen here, and there is, again, this is part 3. So in each one of these parts, you'll have to take things. So you see, there's 1, 2, 3, minus 6, and this actually, I think this taking this data, well, it adds up to minus 4, I think, right? No, minus 2. Okay, so it's taking plus 6, minus 6. So it's actually taking plus 4. So plus 4 minus 6 is minus 2. This is the Ike version. Let's make quickly the 8 version. So the 8 version is the best, the last one here, 2 with 2 long bonds again. Go ahead and put on 2 long bonds. And this one we need to make sure we have an octahedral. An octahedral, by the way, has 6 sides. Okay, so there's 4 on my fingers I'm putting in holes and then top and bottom, right? So you need the octahedral to make sulfate. Okay, so you need 2 reds with 2 long bonds. So 2 different reds are going to make long bond, double bond situation here. So let's put one on first, robbing one of the older sets here. And then we're going to put a second oxygen. That's why we need an octahedral here. One more. And get rid of these. Another short bond or long bond. Okay, so now we got two oxygens that have double bonds, right? And now we're going to add the third and fourth. We're going to just have single bonds. So go ahead and add quickly here. The video's getting long on me. Okay, so there's 1 and 2. So again, see how sulfate has 1 more oxygen than the ite. So this is sulfite, this is sulfate. Okay, this is peroxide. So again, take a picture of these 3 molecules. Now you will see sulfate especially a lot, just like we will see over and over again. Where's my phosphate? Did I take it apart already? Might have. Where's my phosphate? Yeah, I took it apart already. So I stole all the oxygens off that. So you should have 3 pictures here. One with just the carbon and the silicon version, right? I've already cannibalized the oxygens off of it. And then you have a picture with the nitrogen, nitrite and nitrate, and the phosphate, right? Phosphite is kind of grayed out here. All right, so and then with the last picture, you'll just do the 2 oxygen with sulfur, sulfate, and the again, that looks like normal oxygen, but it's actually called peroxide. Okay. All right. So again, do a little summarize in a paragraph what you learned about these groups and the oxygens in this case. These are all negative ions, right? They all combine as if they are like an iodide or a chloride or something. So the polyatomic is something that works as a unit and has an overall charge because it has more negativity than it does positivity in most cases. There's only so many protons sulfur has, and they're all tied up with oxygens, which each have 2. So these 2 are kind of out of the picture because they have 2 bonds, but these 2 still have charges available, right? So that's how the polyatomics work, and that's the purpose of this lesson.